Hello again, welcome back to our course in college algebra. We are continuing our discussion of functions. In a previous video in this course, we demonstrated how to find the domain and range of a function if we had its graph. And in this video, we will show how to find the domain, really just the domain. We'll talk about the range later. But finding the domain of a function if you have the formula rather than the graph. Now there are only two things that you need to work on, and the first of those is division by variables. The reason being is that we cannot divide by zero. Okay, division by zero is undefined. And I'll just give a brief explanation here, right? So I can talk about division by 2. So 6 divided by 2 is 3 because 3 times 2 is 6. Okay, so whatever the quotient is, I should be able to take the divisor times the quotient and get this. So what if I were to talk about this? So 6 divided by 0 equals blank. Well, that would be equivalent to saying 0 times whatever I put in the blank is equal to 6. And this is trouble, because no matter what I put in this blank, well, 0 times that is going to be 0. I'll never get 6, no matter what number I put in that box. So there is no number I can do that will make this work. So division by 0 is undefined. Okay, so that's why we have to be careful if our function's formula has instructions that cause us to divide by a variable. And the other operation that we need to be careful about is taking roots, in particular square roots, but also fourth roots and sixth roots. Any even roots can be a problem. So I'll give you a couple examples of what I mean. So examples. Find the domain. Okay. So number one, let's do f of x equals 2x minus 3 over x plus 4. Okay, so we have discussed function notation in a previous video. Remember, x is the input, so this is instructions for finding the output here on the right hand side. The instructions say take the input x, multiply it by 2, and then subtract 3. Hold on to what you get there. Another step you got to do is take the input, whatever it is, and add 4. And then take what you got from doing this process and then divide by the result that you got from adding 4 to the input. Okay, so the last thing you would be doing to evaluate the output for this function is the division. Okay, well, this would be trouble if x plus 4 were equal to 0. Okay, well, of course, that's equivalent to saying we have trouble if x equals negative 4. If x were equal to negative 4, then we would have to divide by 0, but that's undefined. So there wouldn't be a way to compute the output. And when you're dealing with a function, every element in the domain has to be associated with some output value. Okay, so everything in the domain has to be paired up with exactly one output value. And the x value, negative 4, can't be associated with any output value because we have to divide by 0, which is undefined. Okay, so the domain is everything except 4. So I can use anything less than 4, that's fine. I can also use any x value that is greater than 4. I just can't use 4. If you go back and look at our video on interval notation, you'll see that the interval notation for this is negative infinity to 4, unioned up with 4 to infinity. Okay, so this is the domain of my function right here. Notice the numerator being 0, that's fine. You can have a 0 in the top of your fraction. It's having a 0 downstairs that's trouble. So if your function involves division by a variable, take the denominator, set that equal to 0. That will tell you what is out of the domain. Your domain is everything else. So here there's only one thing that's excluded. Oops, it's negative 4, not positive 4. So let me put the negative signs right in there. So we can use any x value less than negative 4, we can use any x value bigger than negative 4, we just can't use negative 4. The interval notation for that would be right here. Let's do another couple examples. Okay, so same instructions. Find the domain of this function. Let's do f of x equals the square root of 3 minus 2x. All right, so the instructions are telling us, okay, take your input x, whatever it is, multiply it by 2, then do 3 minus that result. Once you've done that, take the square root. Okay, so the last thing you do is take the square root. Now you probably remember from your previous math course that taking the square root of a negative number can cause problems. Okay, we actually saw this idea in a previous little video here. So I'm going to take a number and square it. Let's say I want to take a number and square it and get negative 1. Okay, well, if I take a positive number and I square it, I'm doing a positive number times a positive number, so the product would be positive. If I take a negative number and I square it, well, there I'm taking a negative number times itself. A negative number times a negative number is also positive. So there's no positive number that will work for this. And there's also no negative real number that will work for this. Those of you that have seen complex numbers, you might know how to answer this problem. But as far as the real number system goes, there's no real number x that I can put in this box to make this equation work. Okay, so what I need is this expression being greater than or equal to 0. Having 0 under a square root, that's allowed. Square root of 0 is 0. Okay? But I can't take the square root of a negative number and get a real number output. So we want that to be true. Okay? And here we're dealing with an inequality. So what we want to do is the strategy is get x by itself. Isolate that variable. We want to solve for x. Get x on one side, everything else on the other side. Okay, if I want 3 minus 2x to be greater than or equal to 0, well, if this is true, then negative 2x must be greater than or equal to negative 3. Okay, I got to get rid of that multiplier of negative 2, so I would divide by negative 2. Over here I'd have an x, over here I'd have 3 over 2, the two negatives cancel each other out. Now, here's something you might remember from one of your previous math courses. If you have an inequality and you multiply or divide by a negative number, you have to reverse the direction of the inequality. If you multiply or divide by a positive, just leave it. If you multiply or divide by a negative, you have to reverse the direction of the inequality. So, if we want to be able to compute the output for this function and get a real number, we have to have this inequality being true, which is equivalent to this. Okay, so we can use any x value that is less than or equal to 3 over 2. So the domain of this function is negative infinity to 3 over 2, bracket on the end of this one, because I'm allowed to use this value, 3 over 2. Okay? And I can use anything less, but I can't use anything bigger. All right? So the two cases that you need to worry about for finding the domain of a function are division by variables and stuff with roots. Now let me do one more example, just so you don't get thrown off by an easy one like this. Let's say f of x equals x squared minus 5x plus 1. Okay, here there is no division and there are no square roots. I can apply that procedure to any real number that I want. So the domain is all real numbers. And that's how we would write it using interval notation. The domain is negative infinity to infinity. Okay, so if you have a function's formula, you can figure out the domain. The domain would be any x value for which the formula is defined and gives a real number output. Okay, so you only need to be careful about division by variables and roots. If you have division by variables, look at the denominator. Figure out where the denominator is equal to 0. That tells you what's out of the domain. If you have roots, you want the expression underneath the root to be greater than or equal to 0.